Section 2.2 video, part 2. And I want to continue off with what we just left off with in part 1 video. And I want to start out with giving you this note. So please take this note down that I'm about to give you. Here's the note. Most equations containing two variables has an infinite number of solutions where each solution is expressed as an ordered pair. All right, and remember you can pause the video there when you're taking your notes. All right, so here's what this note just says. Most equations containing two letters, like this one up here, it contains, the answer to this equation up here is a pair of numbers. But not only is it a single pair of numbers, it's millions of numbers. So there's millions and millions of these answers where every answer is expressed as an ordered pair. So for that reason, you will never see, slide this down. Look right here. What does the instruction say above this problem right here? It says solve. You will never see in mathematics, typically, you will, in this course for sure, you will never see, whenever you're dealing with an equation with two letters, you will never see the instructions above it that says solve. Now, why will you not see that? Because it is not possible to solve it. You can't, why is it impossible? Because it has billions of answers. You can't write out all the answers to this problem. Remember what we said in the last video? These answers just go on and on and on. So I can't write out all these answers to this problem. Start out and take another note. Equations with two variables typically has an infinite number of solutions. And that's what the first note said. The first note said we'll have an infinite number of solutions. Continue the note. For this reason, we do not solve these equations. We will graph them. Okay, so you say, all right, Mr. Ryan, I think I got it. So you're not going to ask me to solve this. That is correct. Why am I not going to ask you to solve that? Because there's too many answers to it. There's billions of answers to it. So what I'm going to do, instead of asking you to solve it, I'm going to ask you to graph it. Now, you say, okay, I think I know where we're headed with this. So what we're going to do here is we're going to take these points, these ordered pairs, and plot all of these. So like 1, 4, to the right 1, up 4. 2, 3, to the right 2, up 3. So we're going to plot all these points right. And then we're going to connect these points, correct. And we're going to get some type of picture. That's exactly right. And you say, okay, then that's not that bad. It's not. But here's what I need, another note I need to give you, or I will give you in just a few minutes. But before I do that, let me kind of tell you where we're headed here. In algebra, when you first learn how to graph, what you did when you were first taught to learn how to graph, whether it was 4th, 5th, 6th grade, just depending, on your mathematical background, what the teacher would do is they would give you points, and you'd plot those points, and you'd connect those points, and to see what sort of shape you were drawing. Probably a lot of you in here, a lot of you that are listening to me, maybe remember doing this. Whenever you go to when you were little, you'd go to a restaurant, and they'd have these placemats, and you take these placemats, and you usually a crayon or something like that, or maybe you've done this in school. And there's dots on a graph, and there's like number 1, and they're numbered 1, 2, 3, 4, 5, 6, 7, and they're all over the place. And so what you do is you connect the dots 1, 2, 3, 4, connect them in order, and then after you connected them in order, you could see what the picture looked like. Now, but a lot of times before you connect those dots, could you really tell what the picture was going to look like? I mean, maybe sometimes you could, but generally you didn't know what the picture was till you did what? Connect the dots. In mathematics, we have to do it backwards. In mathematics, you have to know what the picture is before you connect the dots. Let me explain why. I'm fixing to put some dots up on a sheet of paper. I'm going to do one first real easy. And I want you to connect these dots in your head. All right. So here are the dots. So what I want you to do in your head, and you don't have to literally write this down, but in your head, I just want you to draw, connect these dots and get a picture. All right. If you've done that in your head, you got the picture. Okay, so here's what I'm about to do. I'm about to connect these dots, and you tell me if when I connect these dots, if this is the picture you have in your head. Here's the way I connected them. Here are the dots. Now, question. Did you connect those dots that way? No, you did not. What did you do? You drew a line straight through those points. Here's why. What you did was you made a dangerous, but what we often do in mathematics, a dangerous assumption, and that's this. You assumed if you have a dot right here and you have a dot right here, you go from here to here just by going straight to it. If I have 2 dots on a sheet of paper, I don't have to go from here to here just by going straight to it. I could go way up and come back down. I could go down and come back up. I could oscillate 4 or 5 times before I get to it. I could do all kind of crazy things. It's like when you're going from one house to the next. Whenever you're going from one house to the next, do you always get to just go straight to it? No, typically not. Why? Because there's usually trees in the way and woods in the way and creeks in the way and fences in the way. So you may not always be able to go straight to it. In mathematics, it is important that you know how to connect the dots. So if I got a dot here and a dot here, you got to know how to connect them. You got to know the path to travel. So what I've got to do when we're dealing with these equations is I've got to show you how to look at that problem and tell when you graph a lot of the ordered pair answers, how you can tell what the picture is going to look like when you connect the dots. Let me show you why. Don't write these down. You see these 3 equations? Now, let me ask you something. How many letters do you see in all 3 of these equations? You see 2 letters. You see 2 letters in this equation, 2 letters in this equation, 2 letters in this equation. So, what does that mean then? It means, remember I gave you a note that said, most equations containing 2 letters has millions of answers. So I would not ask you to solve these 3. But I told you that I would be asked to graph these 3. So in order to graph these, you'd have to plot a bunch of these ordered pair answers, which we have not talked about how to do yet. But you take these ordered pair answers and you graph them, and then you draw a picture of your graph. Now back to what I was asking a while ago. Do you agree that these 3 equations look very, very similar? this one and this one's the exact same thing except the x is squared. This one and this one's the exact same thing except the y is squared down here. So that is 3 different equations. Let me show you how different these 3 pictures are if we was to plot points and see what their graph looks like. It turns out, you don't have to write this down. This one, if you graph it, looks like that. This one, if you graph it, looks like that. And then this one, if you graph it, it looks like that. So you say, boy, that can get confusing. You're right, it can. So here's what I've got to do. I've got to give you a note on how to tell what the points are going to do. In other words, are they going to make a shape? And then how to graph it. Now, before I give you that note, do all equations with 2 variables, do their graphs make a particular type of shape? No. There are some graphs where their graphs are all over the place. We do not study those in this section. We're only going to study equations with 2 variables whose answers, when you start plotting them, make a geometrical shape. For instance, you'll see, before we finish this course, we're going to graph some equations whose answers make a straight line, whose answers makes a U shape. We call that a parabola. And some equations whose answers make a perfect circle. But before we can get to how do we graph those, I have to show you how to identify them. So let me give you this next note. Take down this note. In this section, we will study equations containing 2 variables whose solutions form a circle. So, in the problems we're about to do, every one of these problems, if you do a whole bunch of points, their points make a perfect circle like this. All right, so I've got to show you 2 things. I've got to first of all show you, let me put this back up. What distinguishing feature makes this right here be a circle? Why doesn't this one go to that? Or why doesn't this one go to this one right here? So I've got to show you how to identify what is the graph of it going to look like. And then the second thing I have to do is then show you how to actually graph it. All right. Take down this next note. Well, I'll tell you what. Let me show you one other thing before I give you that note. You don't have to write this down. I just want to show you something right here. If I have this equation right here, x squared plus y squared equal 9. Never mind what it is or anything like that. What I want to do is I want you to watch. Well, I'm going to try to come up with some ordered pairs that make this equation true. All right, so let's see. Would you agree with me that the ordered pair 3, 0 is an answer to that equation? Because if you let x be 3, what's 3 squared? 9. If you let y be 0, what's 0 squared? 0. And 9 plus 0 is 9. So the ordered pair 3, 0 is one solution to that problem. But so is 0, 3. If you let x be 0 and y be 3, you still get 0 plus 9, which is 9. Now, not only that, let me do a couple of others. Is negative 3, 0 a solution? Yes, because if you square negative 3 times negative 3 is what? 9, and 9 plus 0 is 9. Now, what about 0, comma -3? That works too, because what is 0 squared? 0. Plus, what's -3 squared? 9. And 0 plus 9 is 9. So that is 4 answers. Now remember, this problem has millions of answers. That's just 4 of them right there. You say, okay, I know what another one is, 2, comma 1. No, 2, comma 1 won't work. Here's why. Let x be 2. 2 squared is 4. Plus, let y be 1. 1 squared is 1. 4 plus 1 is not 9. So 2, comma 1 doesn't work. Now, let me say 2 things about this before I move on. This problem has millions of other answers. But it turns out, never mind why right now, it turns out these are the only 4 ordered pairs where both that are whole numbers. These are the only whole number ordered pairs that work. All of the other answers has crazy little decimals in it and stuff like that. So don't think by any stretch of the imagination this is the only 4 answers to this problem. It's the only 4 whole number ordered pair answers to that problem. Now let's graph these 4 points and let's look and see where they're located. This is the x, this is the y. If I plot the point 3, comma 0, that's to the right, 3, and stay there. But if I plot 0, 3, that would be none left or right, up 3. Now, -3, 0 would be to the left 3 and stay there. And then 0, -3 would be none left or right, down 3. So, look at where those 4 points are in relation to each other. This one, this one, this one, and this one. Now, if I connect those points, it appears that the graph is a circle that goes through those 4 points. Now, let me say once again, and you say, well, Mr. Randall, how do you know it's not a diamond? We don't yet. You're about to know, because I'm going to give you a note. But, so it's a circle that goes through those 4 points. Now, let me say again, don't think that those are the only ordered pairs. There's an answer here, there's a point there, there's a point there, there's a point there, there's a point there, there's a point here, there's a point here, etc. You're tired of hearing me say that. So, what this means is, every point that is on this graph is just as much of the answer as these 4 are that we use to draw the graph. So what are we doing when we really draw a graph? When you draw a graph, you're not really just painting a picture. When you draw a graph, you are showing a picture of all of the ordered pair answers to that one particular problem. So when you graph an equation, in a sense, you are solving it. When you graph, that is a visual representation of all of the ordered pair solutions. So all of these millions of points, it's all along this circle, and there are millions. All of those ordered pair answers is a solution to that one problem. All right, coming up in the next video is the very, very important notes that I need to give you, but I just don't want to start them right now because I'm at my 20-minute mark now on this video. So we will stop right here and we will continue with section 2.2 video part 3 in the next video.